Hi, myself Dibyendu Banerjee, and I have done my master's degree from National Institute of Technology, Durgapur, and I have 5 years of teaching experience. I have been teaching foundation course, that is grade 11 and grade 12, along with it JEE main and for NEET 2. So I generally teach chemistry because my master's subject is chemistry, physical chemistry. So my today's topic, so we will learn Grignard reagent today, which is one of the most important parts in organic chemistry. So we will learn today about Grignard reagent. So first of all, we have to understand what is called reagent. So reagent is basically a particular substance which will be added to the reactant side so that the reactant can be converted to the product side in case of any reaction. So this is called reagent. Now what is Grignard reagent? Before understanding the Grignard reagent, we have to know one term that is called organometallic compound. It's organometallic compound. So Grignard reagent is a type of organometallic compound. So first of all, we have to understand what is organometallic compound. So from the name itself, it's clear that it's organo and metallic. That means there should be one organic compound attached to a metal. So here carbon will be directly attached to any metal. So let's take magnesium here. So carbon and magnesium. So there should be some bond between carbon and magnesium, that is the organic part and the metallic part. This is called organometallic compound. Now for Grignard reagent, the general term is RMgX. Grignard reagent can be denoted by this RMgX, where this R is any alkyl group. Any alkyl group. It could be methyl, it could be ethyl, it could be propyl, it could be anything, any alkyl group. And what is X? X is basically halogen. So it could be fluorine, chlorine, bromine, iodine, anything. So basically this is called Grignard reagent. Now we have to understand one thing, that whenever Grignard reagent dissociates, it will become R minus and MgX plus. So the negative charge will go over the alkyl group and the positive charge will go over the magnesium. So this is called Grignard reagent. Now we have to understand the preparation of Grignard reagent, which is one of the most important parts. So for the preparation, so now we will talk about the preparation of Grignard reagent. So preparation. So in case of preparation, we will take alkyl halide as the reactant. So let's take any alkyl halide. So let's take Rx. This is an alkyl halide. So R could be anything, X could be anything. So I have taken a general term, that is Rx. Now along with it, I have added magnesium metal inside dry ether. Dry ether. So what is that dry ether? Dry ether is basically acts as solvent here. So magnesium and dry ether. Now the magnesium will be incorporated inside the alkyl halide and it will become RMgX, that is Grignard reagent. So this is the preparation process of Grignard reagent. So we have to add magnesium inside dry ether to the alkyl halide and we will get the Grignard reagent. Let's take one example. So for example, suppose if I write CH3MgBr. What is that? This is called methyl magnesium bromide. This is called methyl magnesium bromide. So it's methyl magnesium bromide. This is a kind of Grignard reagent. Now we have to understand one more important thing, that is why it's so much important in organic chemistry. So Grignard reagent is basically highly unstable. So to understand that, let's write one Grignard reagent, that is one general term. So this is RMgX. This one is RMgX. Now when we will dissociate it, it will be dissociated into two parts. One is R minus and MgX plus. So this is RMgx, which will be dissociated into R minus and Mgx plus. Now look at this. What is this? This is the anion, that is the negative charge on the alkyl group, which is highly unstable, because whenever we are writing any kind of alkyl group like CH3, so positive charge should be stable here because of hyperconjugation or inductive effect in case of higher alkyl. But negative charge is highly unstable on alkyl group. So this will be highly unstable. And because of this high instability, this will become high reactive. So it will become highly reactive. And this is the moiety which will react with the organic compounds, which we will see in further slides. So because of the instability of the negative charge on the alkyl group, the Grignard reagent will become highly reactive in case of organic compounds. Now we have to see its application. Now let's start with the application of Grignard reagent. So here we will learn about the application, some of the applications today. So first of all, reaction with acidic hydrogen. So reaction with acidic hydrogen. So if there is some acidic hydrogen, Grignard reagent will react with that acidic hydrogen and capture the hydrogen to form an alkene. Sorry, it's an alkane. So here we will see that. Okay. So let's take one Grignard reagent. Suppose RMgx. This is a general Grignard reagent. Now suppose I have added R-OH, that is one alcohol I have added here. So what will happen here? Look, first of all, the very first step would be you have to dissociate the Grignard reagent. So after dissociation, we know it will be R minus and Mgx plus, right? So it will be R minus Mgx plus. So this R minus will be the reactive moiety. So it will capture the acidic hydrogen here. So this hydrogen inside alcohol is the acidic hydrogen. It will capture the acidic hydrogen and will become RH. This will be the major compound, that is alkane. So this will be your alkane. So Grignard reagent will capture the acidic hydrogen from any substance, from any organic compound to form alkane. So this is one of the applications. And the next one more important application is called addition elimination reaction. So the next thing is, so application number 2 is addition elimination reaction. Addition elimination reaction. So let's take one example. So suppose I have one Grignard reagent, that is RMgx. It could be anything. Suppose along with it I'm adding one ketone, RC double bond O R. This is one ketone, R dash C double bond O R dash, because the alkyl group here are different. So what would be the product? So first of all, I told you that you have to first dissociate the Grignard reagent. So let's dissociate it. After dissociation, it will become R minus, which is the reactive moiety. Now, if I look at the ketone, so the ketone has one active carbonyl moiety, C double bond O, and the carbonyl character is very high. So in case of this R minus will attack. So let's start R dash C double bond O R dash. So this R minus will attack here, and the double bond will break towards the oxygen, because oxygen is more electronegative than carbon, and it will become R dash CO minus R dash and R here. Now, since in the reaction medium we have water, that is H3O plus, so it will take the proton, the acidic hydrogen from the water, or H3O plus, let's say, and it will become R dash C OH R dash and R. That is 3-degree alcohol. This is the addition reaction. Okay, now we will talk about the elimination reaction. So whenever we are adding ketone with the Grignard reagent, so our result is 3-degree alcohol. Now what if we add alkyl halide or acetyl halide, not alkyl halide. Here acetyl halide. What if we add acetyl halide along with Grignard reagent? So let's see that. Suppose we have a Grignard reagent CH3MgBr, that is methyl magnesium bromide, and along with it I'm adding acetyl chloride CH3COCl, acetyl chloride. So what will happen here? So first of all, what is our first step? So our first step is, I told you, so our first step is you have to dissociate the methyl magnesium bromide. So let's dissociate it. So after dissociation, it will become CH3 minus, right? Which is highly unstable and will be reactive. Now this CH3COCl, that is acetyl halide, acetyl chloride particularly here, has one carbonyl moiety. So this negative charge will attack the carbonyl moiety, CH3COCl. So this negative charge will attack the carbonyl moiety and the double bond will break towards the oxygen and it will become CH3CO minus Cl and CH3. Now in this step, this is called addition step. This step is called addition step because the CH3 minus is getting added inside the acetyl chloride. Now if you look at this compound, chlorine is a good leaving group. Chlorine is a good leaving group. So this O minus will come back and chlorine will leave from the compound. So it will become CH3 C double bond O CH3. So this step is called elimination. Elimination. So the first step is the addition, second step is the elimination. Now if I have a larger amount or excess amount of methyl magnesium bromide, that is your Grignard reagent, so what will happen further? So here the reaction will not stop. So the methyl magnesium bromide, again the CH3 minus will attack here and it will break in this way and it will become CH3COH CH3 CH3 after taking the acidic hydrogen from the H3O plus or from the water solvent. So it will become 3-degree alcohol. So in conclusion, if we add acetyl chloride or ketone with Grignard reagent, it will become 3-degree alcohol. What if we add aldehyde in case of ketone? So suppose if we add acetaldehyde, that is CH3 C double bond OH, this is acetaldehyde. So if we add acetaldehyde, the addition reaction will take place and after that we will get 2-degree alcohol. We will get 2-degree alcohol. So when we have ketone, we will get 3-degree alcohol, and when we have aldehyde, we will get 2-degree alcohol. Now if we have formaldehyde, that is HCHO, this is formaldehyde. So if we have formaldehyde, so after addition of Grignard reagent, we will get 1-degree alcohol. 1-degree alcohol. Okay. So these are some of the applications of Grignard reagent. So thank you so much for the today's session.